Hey everybody, and welcome to the Experimental Aircraft Channel's podcast, or what we like to call the EAC Aviation Podcast, where we talk to fellow builders, manufacturers, and pilots about experimental, light sport, and ultralight aviation. Be sure to check us out on the web at experimentalaircraftchannel.com. We have a lot to talk about today, so let's dive right into the aviation conversation. All right, everybody, welcome to the podcast of the Experimental Aircraft Channel. I do apologize. It has been some time. I wanted to say more than 30 days. I'll try to get back on it to share some more aviation news and tech talk and what I call the aviation conversation. Today, we are jumping across the pond to the UK, and I'm going to talk to Tim about electric aircraft. Tim, if you could introduce yourself and where you are in the world.
Good evening, Brian. I am Tim, as you said. We're in England, old England, not New England. We're in Norfolk specifically, so out on the east coast, one of the driest and sunnier parts of the UK, which is always nice. It's also fairly flat, which is handy for short-range electric aircraft, I have to say. We're based at an old USAAF bomber base. It was built in 1942, I believe. There's loads of them around here. You can't drive 5 miles without finding one. So yeah, we're based out of an old blister hangar on some really old concrete in Old Buckingham.
Nice. So there's a section of the UK that actually isn't pure green and isn't wet all the time?
There is. You just have to look for it.
Okay.
No. To be fair, it's pretty grey looking out the window now, but. No, we're if you get over towards the east coast, we get a fair bit of sunshine and a lot less rain. If you're over on the Atlantic side, yeah, you're right. It just rains over there. Nobody wants that.
Well, tell everybody what you are building. Well, I'll tell you. I mean, just for a second here, I am really interested in what you're doing because I'm personally building a Zenith cruiser, and you are building a Zenith cruiser. Except we have wildly different power plants to be utilized in these airframes. So tell us about the project and how it came to be, and then roll into what you're using in it.
Yeah. Well, the project, it is a Zenith CH750, mostly cruiser. It's got the STOL landing gear on it, but other than that, it's a cruiser. So it's got the fixed tail, the conventional rudder, and no slats. That was really built as a test plant for the electric power system we've developed. So what we've fitted it with is an electric motor, which is designed to broadly be a direct replacement for the Continental 0200, which is shown on the plans.
Yep. So the base, I won't say the base, but the factory demonstrator when they came out, that was 100 horsepower Continental. So you're just running with what is already a proven design from the get-go of 100, which this motor you're using is capable of much more. So you're really dialing this thing back and kind of a locomotive style of cruising with it, aren't you?
More or less, yeah. I mean, the flash figures, the peak figures for electric motors are just crazy. You know, we can if you put a slightly smaller prop on it, so you could spin it faster, you'd easily hit 300 horsepower, like 380 foot-pound of torque. And yeah, obviously you can't maintain those sorts of power levels for very long because everything gets really warm and then it gets really rattly and then it falls off and that's bad. But instead of 300 horsepower, you know, it'll run takeoff power at about 120 horse equivalent comfortably for certainly long enough for takeoff power. And yeah, it'll produce sort of 70 kilowatts more or less all day long.
That's amazing. We spoke, I don't know, maybe a month or so ago, and you're talking about this technology, and I was asking about how do you govern this, being that with electric motor technology, you have instantaneous torque. So if you were to just want to have a fun grand day and firewall this thing and shove yourself back in the seat like a quarter mile dragster, you would actually start to bend some things with this motor.
Yes, you have to limit the accelerate. You have to limit the torque in the software.
So you have a kind of a slow start programming?
Um, Sort of. It performs the same function. I mean, in the motor controller we're using, there's I don't know 120 odd separate parameters that you can program to make sure it behaves properly. And I think I shared a video with you a couple of weeks ago of what happens when you get one of them slightly wrong. I don't know if you recall. There was
I heard some noise, but I think there's some braking function you had in there.
Yeah, that was when I ramped the torque request up and I hadn't upped the rev limit, and I basically ran into the speed limit before. There was two algorithms trying to do very different things at the same time at about 120 kilohertz. So yeah, you can make some interesting noises by not quite programming it right.
Gotcha.
But
you know what? Just for fun. Yeah, not that you have like airframes laying around, but it would be an awesome video to see, to have this thing on a test bench, the entire airframe, and you just like ramp this up as fast as you can. Literally see this airframe torqued into a swirl from the torque of the motor.
It's funny you say that.
Oh, really? It's funny that I say that.
No, that's not quite what we're doing, but because the whole idea behind the Nuncats plan is to develop a kit form modular electric power system that we can deploy out into the real world to do useful jobs as quickly as possible. So, we're not building a one-off. We're going straight to a sort of pre-production prototype, if you like. So the motor mount, which is on the plane now, which is what we've been testing with and what we've done a lot of development on, is going to be replaced with the first one off the production tooling. So what we've now got in the fabrication shop is the final jig, and we're going to produce one off that jig, which will be exactly the same as, not serial number 1 through 100, say. But what that does mean, going back to your point, is we do have a spare motor mount, which we probably don't mind bending a little bit just to see how it fails and when.
Yeah.
So certainly after first flight, so maybe when the weather starts getting bad and we've got nothing better to do with our time, we'll put the old motor mount back on, set the prop to insanely coarse pitch, and then throw 260 amps at it and see what bends.
1.21 gigawatts. That's a Back to the Future reference. I don't know if you've ever seen.
I know. I'm just still triggered by the fact that the gigawatts. It's a hard G.
Okay.
But, we don't have gigawatts to play with, sadly. But I mean, we can certainly throw. For enough time for it to break, we can throw 200 kilowatts at it.
Okay. Well, that being said, I'm also thinking competition here wise. I just came back from several.
There's probably a middle ground between the two. Yeah.
Well, what I'm thinking, this has become really popular. There's a young pilot, Austin, that likes to throw his, I think it's a Husky, into beta as soon as he lands in a STOL competition and just have a wall of air pushing. And of course, Patey's done that with Draco. Especially with an electric motor, I would believe you'd have an easy option to turn this into beta and reverse thrust this to stop under shorter, correct?
Yes, yeah. Full disclosure, I accidentally ran it backwards in one of our configuration tests because there was a flag wrong in the software, and we only ran it up to.
Sure, blame it on the software, Tim. Let's just blame it on the software.
I'm not blaming the software. I programmed it. It was definitely me. It was just via the software rather than via a spanner.
I'm gonna use a Back to the Future. I'm gonna use a Back to the Future reference here again, where Michael J. Fox is tuning the amps up, and he stands in front of this giant speaker and strums that first chord and blows them backwards. So, did you get blown back into the hangar wall?
No, it was much less dramatic. What happened was I ran it up to about, I don't know, maybe 800-900 RPM or something, and was just aware of the fact that there really was a slightly odd noise and not a lot of wind. I was sort of hanging my head around the screen going, there's something, have I set the prop to 0 pitch? So I just shut it down, and then as it wound down, I looked at it and went, oh, hang on, I see what's going on here.
Oh, wait. So back up a second here. So not only are you controlling the motor with a motor controller, speed controller, but you have a variable pitch electrically controlled prop?
No. It's ground adjustable.
Okay, okay. I wanted to
When we did our initial configuration test, to make sure the throttle worked and it spun the right way, for example,
I see.
we had the pitch set real fine, just because we didn't need to be producing thrust at that point. We just needed to make sure everything worked.
Gotcha.
And that was when I discovered that I'd programmed it to spin backwards, which would have been embarrassing had there been anyone there to see. But I've just realised that I've probably just told quite a lot of people who never needed to know that
just the
happened.
world, or at least a couple hundred people that might be listening in.
In which case, it's too late for plausible deniability, isn't it? No, that did happen.
Well, on this subject here of adjustable prop, is that not really necessary with an electric motor, because the torque that you have on tap, you could just once you figure out an optimum setting, leave it, because you've got, if you need the torque, it's there to pull that prop.
Yeah, we to a large extent, yes.
Okay.
We went with a ground adjustable prop, partly because in our development program we want to be able to test what the ideal compromise is between short field performance and cruise. And also the chap who imports most of the Zeniths into the UK also imports the French-made Duke propellers, which are quite tasty, and he did us quite a nice price on them. So
I know they're good looking. I didn't know they're edible, but thank you for letting me know you've tried them.
I'm sorry, is that not an internationally recognised euphemism? I'm not that desperate yet. I'm not licking the bug jam off the propellers. But no, they're a decent propeller that has a lot of technical merit, and they're quite easy to adjust. And for the sake of a direct comparison, quite a lot of people are putting them on the UL power engines that develop sort of 117 horsepower or 130 horsepower, which is right about where we're going to be.
Sure. So, I had a chance to not visit the factory over there in France, but the dealer over here in the US did a short segment on them, and I was very impressed with the product myself. They make good quality props. So rolling into the background or the motor, what brand of motor is this, or what type of motor? Talk about the specifics on that.
It's an MRAX, so it's made in Slovenia. I slightly suspect they're mostly made because the guy who runs the company uses them as range extenders in his gliders, and has done for years. But they supply the motors to Pipistrel for things like the E Alpha. They're the little 2-seat trainer.
Yeah. So the Sinus and the Virus and those types of
same family of motors. MRAX,
I'm sorry, I know I pronounced it wrong. The American way of saying those words is sinus and virus, but they say sinus and virus. It sounds sexier when you say it in those ways, right? Hey guys, I just got a virus, not a virus.
I have that every day with an electric motorbike that's made in Italy, so everybody pronounces the name wrong. It's an uphill struggle, but it's that fine line between are you pronouncing it correctly, or are you just being pretentious?
There you go.
Who can tell?
All right, Mary Poppins.
Indeed. Well, let's not get into accents and go down that rabbit hole.
I love it. I love it. No disrespect.
Anyway, it's fine. Anyway, where were we? Motors, we tested a couple of different configurations on the jigs last year. And ultimately, for the first demonstration model, which is what we're power testing now, we went with the MRAX because it's essentially the same motor which is in the certified electric Pipistrels. So it's a lot easier for us to demonstrate that it's an appropriate level of quality and reliability for a permit to fly aircraft if it's the same motor that's already in use in a certified aircraft.
Sure, proven tech.
We're picking our battles. Some of the other motors we've tested are in use in LSAs in Europe, but not full certified and not in the same sort of volume production. So there are more power dense options that we're looking at as well, but not all at the same time, because A very small number of us working basically in a shed to try to do what an awful lot of people think is either not worth doing or not possible.
Hey, I understand that's how Harley Davidson got their start in a shed, right? So hey, look where they went.
Well, this part of the world has a pretty good reputation for things rolling out of sheds and working. So yeah, I'm going to go with it. Hell,
Nice.
even the Wright brothers, weren't they push bike mechanics by trade?
That's right.
Yeah, there you go.
That's right.
Yeah,
So
it'll be fine. If you do it in a shed, it must work. There's some logic for
that's
you.
where all good ideas are born, in a shed.
Or a
Some
pub.
people, even, so. All right. So rolling on to the other tech here is the battery. I assume it's a lithium option. What's the tech behind the battery,
Yeah.
and how do you?
We went with lithium ion. They're 18650 cells, just like Tesla used to use, and they're quite common in a lot of high power applications now. They don't have absolute cutting edge energy densities anymore, but they're known good. They're at a reasonable price point now, and they're good enough to prove the point. There's a lot of automotive OEMs have got solid state batteries just on the horizon, and if we can get our hands on those as soon as we can, we'll use them. But in this version, it's lithium ion in a off-the-shelf cell configuration, because again, it's an easier route to certification. It's not certification. It's an easier route to get the permit to fly in the UK if we're using an off-the-shelf technology in a way which is unremarkable, should we say.
There's a couple other companies that have taken this route with electric and with lithium, and it seems to be this magic round number of 1 hour flight time. I assume that's where you're at with this as well. And what is the limiting factor? Why is this 1 hour magic number keep on popping up here?
Well, I think I've heard this from the other side as well. There's a general consensus that to be a viable aircraft, you have to be able to fly 1 hour with a reserve, 2 passengers with luggage. And those numbers, I think, come from an understanding of what consumers will engage with, what somebody will be willing, what compromise people are happy with. Technically, if you have a aerodynamically slippery, modern, fairly light composite aircraft, you'll still struggle to meet that with a decent amount of luggage on board and 2 people who aren't built like racing snakes. Which is why a lot of the big companies, are either ignoring electric altogether and going straight to hybrid, going via hybrid, I should say, or looking at alternatives like hydrogen, which in the longer term will get them those sorts of the endurance. There aren't that many people who are going pure electric and expecting to hit 1 hour plus a reserve with 2 people plus luggage. What we looked at was the fact that in large parts of the world, especially the developing world, there's just, off the top of my head, there's something like 1.6 billion people who have no functioning access to healthcare. The 1.6 billion people. There's something like 4,500 infant deaths every day that could have been prevented by access to primary healthcare. Now set that against the fact that petrol aircraft have been around for 100 years, and their range is measured in thousands of miles with an endurance of 6, 8, 10 hours. Yet 20% of the world's population has no access to healthcare. Range was never the problem. If you want to drive real social impact, you need reach, not range.
Right. And so to interrupt our technical talk for a minute.
Yeah, I'm sorry.
And talk about the heartfelt talk here. Go ahead, since you're talking about already. Nuncats exists as a humanitarian effort, correct?
Exactly. Nuncats exists to demonstrate that you can increase the reach of light aircraft by making them cheaper, simpler, and more available. So if you take a kit which any school, college, or university in the world can assemble, and you make it run off nothing but solar power, and it use chargers which tie into existing microgrids, we can actually start to reach parts of the world where people have to walk 25 miles to get to a clinic which has no medicine when they get there. Mm. That's not where the world should be in the 21st century. And we can take a lot of this off-the-shelf kit, 18650 batteries, battery management systems that are used in like race cars built by universities, off-the-shelf kit planes, and just by integrating it in a way which makes it simple to assemble and makes it as cheap as possible, delivering that within a non-profit framework is a thing we felt should exist in the world.
So Nuncats, for everybody listening, is the company you started.
Yeah, Nuncats is I don't think you have them in the US. It's called a community interest company. So it's a company limited by shares, but we're legally obliged to fulfill the mission before we make profit, basically. So, we ultimately, if we can, our CH750 with the electric conversion kit on it, we'll do, half an hour around the pattern, easy enough. If your students particularly like, maybe a bit more. But in the first build, we'll be testing half-hour test flights. If you want no passenger, put 2 more batteries in it. You might get on for an hour if you've got a light pilot and no load. But if we can find 10 people in the world who are happy with clean, quiet, short flights for hour building, training, or whatever, if we can find 10 of those to sell the kit to, then instead of making profit off it, we can give one to someone who's distributing medicine up the Congo River Valley, or a midwife in Kenya who can only go out if it hasn't rained, because otherwise the roads are closed.
Right.
And it's a niche application for sure. There are, let's say, 1 in 100 sport pilots would be happy to have that short range. But 1 in 100 sport pilots is enough pilots that we could put 10 or 15 of these out into the real world every year. And 10 or 15 of these in the real world could be saving hundreds or thousands of lives.
Yeah,
and awesome. that's a non-trivial change in the world.
Yeah.
The world would be a better place if it existed. So we set up a company to prove that it could be done.
That's awesome.
And then 6 months later, there was a plague. So
there's always something pushing back against your ideas, right?
But yeah, I don't believe in such things. It's all fine.
All right, so going to in the field here, you got this plane that will have roughly an hour plus reserved for safety time in the air, and that will have to run on a schedule. I'm sure you can't just probably firewall it the whole entire time. You'll have to get into cruise configuration to be able to extend that range, just like any other aircraft. But once it gets to a destination, what does the infrastructure look like on the ground to be able to charge and get back into the air again?
Well, it depends on. We've got two basic models. We've got a sort of home station, if you like, which is what we're building at Old Buckingham at the moment. Actually, that's why I've got concrete on my coveralls today instead of grease. Which is a sort of solar shade. It's like a carport, but big enough to put a cruiser underneath. The roof is entirely solar panels. It's got a big box full of lead acid batteries, and it's a normal microgrid. So you've got inverters that make the solar charge the batteries, and the batteries charge the plane. And off one of them, you could, in summer, 3, maybe 4 flights a day without ever getting any fuel off the grid. Out in the wild, so to speak, it's a slightly different model, because you wouldn't be doing multiple charges per day. You just have to know that the once a week you go to a particular clinic, the batteries will be charged. So you only have a couple of solar panels in that sort of application.
And what's the charge time? What's the charge time with using just solar or grid power?
Oh, well, no, you still go, the solar or the grid charge a lead acid ground battery. So that's a normal, like, off-grid battery that you'd have in your cabin or whatever. The charger that goes DC to the plane, the first one that we're using at the moment, it's about 3 hours there or thereabouts. But to be honest, that's because we don't want to give the batteries a hard time, and I haven't turned it all the way up to 10 yet. Okay. We're going to be replacing that. That only runs off a single phase, so that's a single phase 230-volt charger. We're going to put 2 more phases on the system and then have a 20 kilowatt charger, which will charge the plane in 80 minutes, there or thereabouts.
Wow.
And we might be able to go a bit faster, but then we're into the realms of experimental.
Yeah, start cooking batteries.
Well, it's not actually the battery isn't the limit, because you're always going to be charging it slower than you're discharging it in the air. So it's not so much overheating the battery; it's about the balancing resistors. When you're in the sort of middle of the charge range, between say 10% and 80% state of charge, you more or less just throw current at it and it's all fine. Yeah. But as the battery gets full, the slight differences in cell capacity starts to show that some cells are more charged than others in percentage terms, and you can't overcharge them. So the cells that have the slightly lower capacity charge slightly faster, and you have to dump power out of them so the rest of the cells can catch up. And the systems that do that are the limiting factor on how fast you can get a full charge into the battery system.
Okay. What are you predicting the cost will be to build one of these charging stations?
Oh, surprisingly cheap. And that's all you're getting out of me while we're building the prototype. No, honestly, literally today I've been talking to some of our suppliers and some of the contractors we're working with to try to pull together the actual final costs, because with a small team working on finishing the airframe and finishing the power system testing and finishing the ground power systems as well, there's a couple of loose ends we're in the middle of tying up. So I'll get back on that. Ask me next month.
Actually, next month. You mentioned, I was asking about the cost of stuff, and you said, ironically, one of the biggest expenditures for this is the connectors, right? From the battery to the charging station, or even to the motor?
Well, yeah, one of it's a side effect of why we're doing it, ultimately. You'll know, if you're wiring an aeroplane, generally, you take a wire from source to load, and you don't put connectors in it. You don't absolutely need. But ours has to be a kit which anyone can assemble, and it has to be able to be retrofitted to an existing already built plane, which means there are more plugs than you could get away with. So yeah, we've got the connectors on each battery module have parallel power pins and then bus communication pins. There's a few pins for the safety systems and the emergency disconnectors. So by the time you've got one of those on each battery module, with the over center catches to make sure they all stay locked up, and the ingress protection on them, you end up with actually quite a reasonable chunk of the budget in terms of mass and money actually is just spent on the incredibly boring things like plugs and sockets.
Ironic.
Slightly, but it turns out
other difficult challenges, and then the expenses down to the little nitty gritty stuff.
Well, absolutely. I mean, you would not believe how many sets of crimping pliers we now have on the asset register. The answer is several. I'm not counting them for you.
Yeah. Well, when do you think this thing is going to be taking flight? You obviously have been ground testing this now, and what is the plan to get it into the air and see what it's going to do then?
Well, we are, the configuration testing is more or less done. So that's everything does what it should and goes in the right direction. We're on a bit of a pause at the moment in terms of power testing, because we're getting ready for the air show at the end of the month, where we'll be taxiing it about for people to look at. And then after that, we get back to the full power testing, fast taxi testing through August, we might just about do a first flight in August, but if we get it done in September, I'll be happy.
Nice. Well,
and then thereafter, we've got we've got to build some time in the pattern at our airport so we can get in the UK at least, will be issued a permit to test by the LAA, which essentially allows us to get in the air and start putting hours on it. And when they're satisfied that it does actually work, then we get a permit to fly, which means we can roam around the countryside. And off the back of that, we've got 7 other airfields around the county where we're going to put the small chargers in, so we can start demonstrating that even if you do compromise the range by using a fairly high drag airframe and a fairly heavy aircraft with relatively small batteries, we can still bounce around a county the size of Norfolk, powered by nothing but sunshine, getting in and out of short dirt strips. And even at that point, there will be people who say that the range is too short to be useful. And we'll point out that even in cases where that's approaching true, as long as the sun keeps shining, we keep flying. The roads can close, we fly. The grid can fall over, we fly. That's one of the big untapped benefits of electric vehicles in general, is the resilience they can afford. Because once you've got the vehicle and you've got the generation assets in place, it's a standalone system that needs no further external input.
Let me ask you a couple other parting questions here, and that is what we've seen the tech in automotive with the regenerative, like braking and stuff like that. Let's say that you're using this as another asset as a trainer, and you're in the pattern doing pattern work. Obviously, you're going to expel a lot more power on takeoff and climb than you would to regenerate. But when you pull that power back when you're turning crosswind or downwind, or maybe midfield downwind, what's the amount of regenerative power you can get from the prop spinning that motor back, or does that not work in this application?
Well, the hardware we've got installed has the capacity to do it. The aerodynamics of it don't really make much sense.
Okay. It's a draggy airplane, so you pull the power back, you're dropping anyway. So you're not really...
You just stall the prop.
Okay.
You just stop you could configure it to pull a little bit of power back.
Yeah.
I haven't done any detailed studies on exactly where that level would be before you do just stop the prop. But it's certainly not something I've looked at in any great detail, because the consensus is it's a lot more complexity and a lot of time setting up something that doesn't really give you
or
much.
You simply will be training a lot larger numbers of glider pilots in the future then.
Well,
stop the prop.
Everyone's concerned about engine stoppages. Every glider pilot, every landing's dead stick.
Every landing in our airplane is dead stick.
Yeah.
I mean, you get midfield downwind, you don't need a propeller, right? You just glide the rest of the way down.
I don't think we can turn base to final and then recertify it as a glider.
Why not? Then you can have an hour and a half of runtime in your system there than an hour.
Yeah, no, it won't surprise you to hear that over the last couple of years that there have been all sorts of interesting suggestions from various friends of mine, usually on a Friday night, sometimes at the bowling alley, where people have come up with ideas significantly more crazy than that.
Beer in bed.
But actually, I mean, there is I can't remember what they're called. There's a company, your way of the world, who are developing an electric STOL plane for short-range cargo operations.
Mm.
And what they're doing, I don't think it will make... sorry, chair failure. I don't think it will make it from the renders to the prototype, but they've got regenerative brakes in the wheels. So instead of relying on the propeller to do the work on the ground, it's much more efficient to use motors in the wheels to get you up to rotation speed, and you only use the prop once you're basically flying. And conversely, as soon as you touch the ground, you can use the wheels to regeneratively brake. And that was something we did look at, right back at the beginning. But the fact of the matter is, it's just too much complexity and cost and it's just extraneous to what we're trying to do because we think these can be surprisingly cheap, and there will be places in the world where they do fill a niche
Yeah.
and do useful stuff.
So the other side of that tech question for this, talking about solar stuff and electrical, um, you've seen people talking about putting solar cells on roofs as shingles. I'm sure the tech will only get better and perform better and thinner and stuff like that. Is there anything that exists right now today that you could replace your top skin of your wing with a solar panel cell that would, I don't know if you could fly off one battery and one, like, go back and forth. One's charging for 5 minutes, one's drawing, and switch over. And then is there anything that exists like that that would be useful or no?
Potentially, yes. I mean, there was NASA flew a solar plane the whole way around the planet on exactly that technique. There are various issues in doing it in the world of traditional construction STOL planes. The surface area of the wing isn't really big enough.
Well, Zenith is a flying box kite, so you've got the whole tail section that you could cover that with as well, right? So
yeah, you could. I mean, it's funny you say that because I took a photo when I was over at the hangar this morning. All the solar panels for our first charger just got dropped off this morning. So I took a photo of this big old crate of solar panels sitting in front of the plane. And I was going to caption it something like, for all the people who keep asking why I don't put solar panels on the wings, this is how many solar panels you need for 3 flights a day. It's a pretty big crate of solar panels, to be honest. You could do it. The technical issues, as much as anything, is you can't get enough volts off that much solar to directly charge the batteries as a whole. So you'd have to split the battery bus into its modules and then charge them sort of one at a time, and that's quite a lot of extra switching gear and a lot of complexity in the DC power systems. And the other thing is just the amount of energy you're going to get out of it. The only sort of viable use case I can see for it in off-grid bush plane type operation is if you get to a charging station that you think should be able to charge your plane and it's been shot up or burnt out or whatever, then if you've got solar panels on your wings, you might have to sleep in the cockpit for a day or two, but you'll get charge eventually.
Well, then you could do what is it called? Solar winds. You got solar panels on the wing, and then you flip up these squirrel cages that catch the wind too, and then you're
that's
multiple
more
streams of charging.
Yeah, that's more Mad Max than Star Trek, isn't it? But what was it the man said? Hope for one, but plan for the other.
There you go. Well, thanks, Tim, for jumping on and talk with guys. If you want to see what this guy's mug looks like, we did a short 15-20 minute video on YouTube that I put up, but I wanted to do a longer form here on the podcast so we could get into some more technical stuff. So this is probably 2 or 3 times longer than that episode. But if you want to see what this guy looks like, you can catch this on YouTube as well.
No, why would you do that? Nobody wants that.
All right. So if somebody wanted to follow you personally, how can they find you on social and in the world?
If you search for Nuncats, Nuncats, nothing to do with women of the cloth or domestic felines, but that's how it's spelt. We're on Facebook is where I sort of do updates on the plane and the charger and all that sort of progress. The slightly more serious social impact side of it is managed by my wife, who's much more sensible and in charge of that kind of thing. That's on the Twitter account. So that's worth a look if you're interested in the kind of NGOs and charities we're talking to about where these might be in the world. And when the cowls are on and after its first public showing at the air show, there'll be a YouTube channel popping up, which will be full of terribly edited, badly shot video, but it'll give you some idea what it looks like in the flesh, so to speak.
Hey, I've always heard start before you're ready. So you have to begin somewhere on your timeline, right?
Indeed, indeed.
So the Nuncats, the name, does that come from like the cats that have none, being that you're humanitarian non-for-profit here, cats that have none?
No, it didn't. We'd come up with the idea. We'd done some feasibility studies. We decided that we could not, even though this is the most ridiculously low-cost electric aircraft, we couldn't quite do it on our own. But if we set it up as a non-profit, we could make a sustainable sort of business out of it. And we'd done all that and we realized we still didn't have a name for it. And we had to file the papers because we needed a bank account to get trading. So we had to come up with something real quick. Nuncats is a sort of portmanteau of two concepts. The nun derives from a principle I cooked up in an R&D job I had a few years ago. No unnecessary novelty. It was what I used to tell people whenever they came to my desk and went, "Oh, we could do it like this." And unless they had a really good reason for this ridiculously extravagant, clever thing they'd come up with, I'd just go, no.
You're that guy. You're that guy, but yeah, here you are presenting this to the world. Look at you.
I'm that guy now. No, because, I think there is a time and a place for novelty, but I think we as a species kind of waste a lot of time on shiny consumer gadget stuff that, let's face it, nobody really needs, do they?
Well, how ridiculous was some of these ideas? Like, Tim, you should really add like a coffee maker to your cruiser.
Oh, no, this was chemical process R&D. So there was people who were coming up with things that was just like, oh, look, we've got this great new heat exchanger. And I talked to one of the other guys about it and we'd go, yeah, what you've just drawn there is actually a hydrogen syngas explosive device. Well done. You're going to go to jail and get killed doing it. Thank you. Go away. So anyway, sorry. The NUN part of Nuncats is the principle of no unnecessary novelty. So, keep it simple, essentially. And the CATS came about because we wanted to deliver community benefit alternative transport systems.
That is like the world's largest acronym then, I think, Nuncats.
Yeah, more or less.
Yeah.
Yeah.
It's so long. I don't think I remember one. I don't think I remember the other one, but now we know.
Yeah, indeed.
Wikipedia.
Now you know. And
can you enter that into Wikipedia so it will show up in Google from now on?
Don't give me ideas.
Don't go there.
I had actual work to do this evening, and now I'm going to spend the next 2 hours writing my own Wikipedia entries.
You see people, you see friends, you see fellow builders. This is why I love aviation. This is what I call the aviation conversation. It's just fun. It's just fun. Well, everybody, thanks for joining us today. Thanks for supporting us in trying to reach more people to get into experimental light sport and ultralight aviation. As you can see, there's all kinds of fun things happening in this industry, in this world. A lot of creative people, a lot of interesting people, and we appreciate you being here. So we'll catch you in the next episode. I will try not to be so long in between these podcasts, get some more people on to talk to while you're working in your shop, in your hangar, in your garage, or driving to work. But we do appreciate you. We'll see you in the next episode. Thanks for downloading and listening to our podcast today. Hopefully you built something in your garage or hangar while listening. That's it for us today here on the EAC Aviation Podcast. I'm out.